I am Subimal Ghosh from Indian Institute of Technology, Bombay, IIT Bombay. I am associated with Civil Engineering Department as well as Interdisciplinary Program in Climate Studies. I am a professor here. And I'll be talking about today on one of the project, which was a collaborative project between Indian institutes and UK institutes, which is on coupled human and natural systems environment, which is in short from CHANSE for water management under uncertainty. The brief objective of this project was to understand the human natural system. So normally, conventionally, when we model hydrology or when we go for water resource management, we consider the water resource systems as a natural systems, where human is also a major important factor. In this project, what we tried to do, we tried to consider human systems and natural systems continuously interacting with each other, evolving a human natural system. That was the primary objective. And while understanding the system, we wanted to help the stakeholders, help the water resource managers in making sustainable water resource decision making. That was the primary objective of this project. The innovative way of looking into these outcomes is something like this. When we are talking about water cycle or earth system science, we know there are multiple spheres, which are hydrosphere, atmosphere, biosphere, geosphere, and so on. And each of these spheres are actually interacting with each other. So we are not taking a conventional view like the information will come from atmosphere, it will go to hydrosphere, then hydrosphere to biosphere, and so on. In this project, we considered all these spheres are interacting among themselves so that we can consider the earth system together. When we talk about science to policy, it's a very important thing. But unfortunately, it has become a buzzword because many of the cases, the scientific findings are not based on the needs of the stakeholders. That's the first thing. The second thing, the scientific findings do not really consider the scenarios in which the stakeholders is actually practicing water management. I'll give you an example. Let's say if you're talking about Indian conditions, where we have been widely using the land surface modeling for Indian hydrology or Indian water resources. But many of these land surface models are neither coupled with a groundwater component, which is very important for India. Many of them do not consider the paddy cultivation. Paddy cultivation is one of the major thing in India where you have to keep the entire cropland submerged. And this kind of conditions are not really considered in many of the state-of-art land surface models. So let's say if you really want to translate science to policy, the most important thing is that how to really understand the need of the farmers or need of the stakeholders and how to really understand the scenarios. And the whole project starts from there. What we tried to do, we tried to start with stakeholders meeting. We met the farmers. We tried to understand in what way they work, what exactly are their needs, and those information we have incorporated in the land surface model. And then we tried to develop different water management practices to help the farmers, to help the stakeholders. We have done few pilot case studies. The whole idea of this project was to first apply the model or apply the science for the entire Indo-Gangetic basin, and then specifically pick up one of the sub-basin. And here we have picked up the pilot sub-basin as Gandak sub-basin. For the Gandak sub-basin, we have again rerun the model, and also we tried to run some of the water management model which can take care of not only the water demand for farmers and different cities and so on, but also we wanted to see how to really meet the flows, ecological flow, how to really make sure that ecology is not getting disturbed. And in that way, we tried to develop water management practices. So we have developed two approaches. The first one is system dynamics approach, which are more or less like data driven, and where we try to consider different components. If it is coming from economics, or if it is coming from water resources, or if it is coming from human, or if it is coming from crop, all these components are linked together. So each of the components are variables and they are linked together. And this system dynamics model, we wanted to understand under different stress condition, how it is evolving, how the different links are changing. And this is the way we have considered the system dynamics model. The second model was, we have picked up variable infiltration capacity model. Then we have coupled a groundwater module to it. We have coupled Indian irrigation scenarios to it. We have coupled paddy irrigation to it. to make it really customized for Indian conditions. Of course, for transferring this model for other regions, we need to understand the situation for other regions as well as the behavior of farmers, the human behavior, the stakeholders' behavior to improve the model. Yes, regarding scientific or technical challenges, one of the things which I was mentioning is that we need to understand the farmers' behavior, we need to understand the irrigation practices of the new region. This is what is very important. And also we need a very good validation data for the new region. One of the major important validation data for any kind of hydrologic model is the soil moisture. And unfortunately, in our country, the soil moisture networking is not very good. So of course, Ministry of Earth Science maintains, India Meteorological Department maintains few soil moisture stations, but that is simply inadequate. We need a huge number of stations of soil moisture, and that network has to be maintained. And with that network and with the availability of more irrigation data from the state governments, this kind of models can really be made usable and useful for all the people across the country. That is what is very important. Even the same thing can be applied for the UK also. The chance framework is designed to help the stakeholders at different levels. We discussed with farmers, we discussed with water resource managers. Actually, we discussed with people at different levels. Let's say from a farmer's perspective, what is important for him is that when to irrigate. But for a water manager's perspective, what is important is that to which village, how much water should I release? So this is what is very important. So actually, if you are considering any kind of water resource management system, it either considers top down or bottom up. But what is required is that it requires a newer blending approach of top down and bottom up. So essentially, we need to understand what is being available, that is using the climate models, weather models, and so on and so forth. And what also we need to understand is that what is the demand for the farmers, and that will go from bottom up. So when you really blend this top down and bottom up and try to understand the interactions between different scales, then stakeholders will benefit. One of the things what we have learned from the stakeholders, like the farmers, we thought of applying irrigation as per when the soil moisture goes below permanent wilting point. We thought of applying irrigation in our model. I'm just giving an example. But when you talk to the farmers mentioned they don't really monitor soil moisture. None of them follows weather forecast or extended range prediction or anything. What they do, they are poor farmers. So what they do normally, they try to manage some money. When they get money, they buy diesel, and when they get diesel, they just irrigate, do a flood irrigation without really understanding whether irrigation is required or not, or whether next 3 days you are expecting good rainfall or not. So this sort of information needs to be considered in the model. And that's why we need to really collaborate with the stakeholders. I'm very happy that our system dynamics model as well as the updated WIC model, both are actually considering the farmers' behavior and the way farmers work in terms of different probabilities and so on. And this is the way we can actually interact with the farmers, take their input and improve our model. In achieving some of our goals, the Indo-UK collaborations were very important. This area is an interdisciplinary area. It is not just focused on groundwater hydrology or surface water hydrology. Rather, it has multiple components. And in both India and UK have different expertise in different areas. It actually helped us to collaborate and come up with a model that can take care of multiple components. We cannot just think of a single component. As for example, for ecological component, we relied more on ATRI. For groundwater component, we relied more on British Geological Survey, BGS. For the climate component, IITM and IIT Bombay work together. So essentially, different institutions have worked together and come up with a combined model that have multiple components. I think one of the best channels through which the collaboration can be established between the stakeholders and organization is through interactions. The interactions are very important. And how does this interaction start? What should we do so that the stakeholders will start believing on us? That's the first thing what we have to learn. And for that purpose, what is required is demonstration. Demonstration cannot be done just in 1 or 2 years. So I cannot ask the farmers that you follow this, you will find good profit. The farmers may not believe us. And it's quite obvious. So what is required is that you have to take past data and use your model and demonstrate that, look, if you have used our approach, you could have saved this much amount of water, or you could have made increase your profit by this much. This kind of information, if you can give to the farmers and then keep on providing your input without really asking them to follow that, but asking them to provide feedback to us. In that way, the collaboration may improve and collaboration may result into better results. We are actually working with some of the farmers in Maharashtra and trying to understand what is the better farm scale irrigation water management policies, considering weather forecast and so on. So essentially, when you talk to the farmers mentioned, of course, IMD provides us weather forecast, but we don't know how to use it, in what way we can use it. So there is always a need of packaging the forecast for the users, and that interface is very important, and that interface needs to be strengthened. It should not be done in a routine way, rather it should be two-way approach, where the forecast community will also provide forecast and the user community will also mention what exactly is required, and a person who understands both can combine them together, or a group of researchers who they can combine them together. And we need multiple national schemes or projects which can fund this kind of activities, and this is very important for technological innovation towards sustainable water management or towards a better future. Thank you.